Good morning, everyone. This is Monday, September 23rd, year 2019. And as we're starting off into the fall, got so many things going on that I'm going to be sharing with you. The discovery that we're leading into that I've been sharing with you guys and been kind of long-winded about, but getting into the system of how this all works and how we're going to get better at it, and my artwork that I'm making from two mouse traps. And what we're going to do is unlock this potential that I've been telling you about, unlocking electrons from the PMH and finding that leverage to come up to our dimension and use that for useful work in the motor generation system. I'm thoroughly convinced that your Q goes up when you have plasma in the system. Like I've told people before, the dielectric, the best dielectric is, of course, the vacuum. And then after that, Teflons, and then on through the various plastics, Lexan, and everything. But I'm going to put a bow together on a proposed system using the switch, okay? And the my switch, from what I've seen, is the seesaw. What I'm after is this rocking seesaw being pulled from the dipolar section in this unit. And when it's done correctly, you create a monopolic plasma. And of course, we're finding out from the Model T spark gap system, when it all started when the light bulb went off for me, is when I saw that. And then one of the things that also I've been able to see, and I'll share this with you, is getting into the symmetrics of your 180-degree coil arrangement, okay, and north, and of course that can be all split up, but the coil being one that's offset 30 degrees, okay, and if you're working with other types, then that separation can be different depending on the widths of your magnet sources that you're using. But this is the basics of the system, and getting the waveform into a three-phase waveform has become really, really simple. Understanding the heuristics of the coils, the inductors, and placement. So we can now make these controllers very, very simple to do what we want them to do. And so just by understanding the telemetry vector of them. I'm going to do my best to wrap this up. My job today is to wrap this up and help you understand the monopolic system, which is biased. Okay, the dipole is still there, but all you're doing is you're taking the ball, if you will, and the small opposite effect is on one side of the ball, leaving the bigger circle of vibrating that ball to find that leverage to make that happen. And as we're at this door of unlocking the monopolar type system, understanding the dipolar type system, using the bipolar system to navigate through the system, and then ultimately coming to the tripolar system, and which as we're getting closer and closer to wrapping that up and putting a bow on it, is a system that is, let me get my book here, in research, in creating the lucite type slab to create the electric. Okay, and the electric being is the electric version of a magnet. Okay, and basically what happens when you do that, you're using electrostatic energy to polarize one side of the electric, and that makes it biased. So with the biased design, that's what you're looking for. Interesting to note, one of the old devices out there, and I found this online this morning, and you'll notice the Model T coil, the Model T point systems are being utilized right there. Okay, and then they have a horseshoe magnet right here with wrappings on both sides of that. And then on the 45-degree angle off of that, they're using the ring to find this system. And then they have a resonating buck and boost coil. And then off that buck and boost coil, they have the secondary winding that was used to light light bulbs on that. Pretty sure that this is a combination battery right here as far as the core. I'm pretty sure that's going to be your battery that you're going to find. And then I'm pretty sure this is going to be your capacitor right there in the line. So I'm pretty sure that these systems incorporated batteries right in plain sight. So don't want to mislead anybody on these type systems that were out there for a very long time ago. This was a primitive looking design, but it leads right into what I've been saying with the system. And then understanding that you have your amperage side of the system and your voltage side of the system. So that's what we're looking for. And the pilot light, again, as I said, is basically this system right here that I've shown. The spark box, like I said, this is the best version I can find of it. If you can find a clear shop drawing of it, this was blown up from a very small pixel unit, but that was hidden in very plain sight. Getting to the basics of the parallel circuit, I'm giving you all the ingredients, understanding the difference in parallel, the difference in series, how they're wound, getting back to those systems, and the zero voltage switching system. And then there's also the zero amperage switching system. And all these ingredients can be incorporated that basically take the same old design and makes it asymmetrical or an unbalanced system that makes the unit work. So with that in mind, we're going to delve into and wrap this up, put a bow on it, and get everyone more familiar with the system that I've been working with now for about 3 years. Now I can see how to make my system even work better than what it's worked before, I believe. With every type system in engineering, I've always found that you lose one thing, but then you gain another. And so we're gonna explore those things. My construction, I'm using popsicle sticks, okay, and then small screws and brads. I'm going to try to make my switching simple, as easy as possible for people to understand what it is that I'm doing, to get people to visually see the seesawing monopolar switching and the pass-through reactance reacting in the coil that makes the motor generator possible. And in the past, I've always used commutators, and I always realized there was a resistive loss through the mica on that system. And so this proposed system is getting more and more into what I call Oriental motor design, or the ECM motors. And with my part of understanding this is we know that we can heat with radio frequency, and that's been done for a long time. The thing is that I believe that we can also cool with radio frequency. And this is going to be made possible by understanding the electret. Okay. And that's what I showed you earlier, is the electrical version of a magnet that's electrostatically charged, electrostatically permanently charged on one side. And to help us understand the lapse rate induction that has the ice cold potential from our construct's atmosphere. I believe the plasma is what makes that possible when it's harnessed correctly and balanced correctly. It's actually a cooling plasma instead of a heating plasma, and we can get it down very cold, which we can get it to the right frequencies, leads us into a sonoluminescent reactance. And I believe they've been actually doing this for years through the common pig pole transformer. I think once we actually understand how that system works, that there's actually a very quiet plasma that's in operation in the pig pole transformer. Understanding the bias electrical metals that they use with the Stratus silicates that they add to the metals to make this happen. Like I said, this is not free energy, guys. The only thing is the discovery that we can get the Qs very high from the potentials that are there. Okay. And thanks to the new batteries that are online, that when you build your motor, like I first turned my motor when I created it, built it, I called it a constant amp motor, because I wasn't changing the amperage to increase horsepower. I was simply increasing the voltage. Okay, and if you have the amperage there, then the voltage becomes very easy. So, like I said, my goal was to create a motor that would run 100 horsepower with voltage, and it does at very high RPM with the mass on it. But when I really tried to overclock it and everything, the lead acid batteries would not handle much past 20 horsepower. They just couldn't stand that high return voltage in the lead acid battery. So putting the whole thing aside with hysteresis memory, understanding how that works, putting the Eli, the Iceman with the parallel circuits and the series circuits of where your resistance is at as opposed to your capacitance. Then demonstrated earlier the sympathetic resonance design of the ferrous materials, and helping people to understand the monopolar, bipolar, and tripolar system, understanding which is lighter, the neutron, the proton, the electron, and the correct answer is electron. So getting the plasma inductors, and then how we can tap that into the resistance of the earth ground to make the electron pump. And I've given you the idea of how that works, is that we're bringing up a high side, dropping it down a low side, and all we need is that little bit of energy to keep the system going, instead of, like I said, on a 120-foot well, pulling the energy through it. So making those connections from the earth ground to the altitude and lapse rate, that actually makes all this happening, because we're tapping into the cool that's above us, but it's way above us, and we can tap this in through inductance. And so getting all this stuff put to simple is my job today. Okay, and helping you understand the difference in polarized plasma and balanced plasma, and that's what we're actually tapping into in the spark gap, with quenching and unquenching it and other things within the different dielectrics, whether it's oil, whether it's vacuum, understanding how to flip the math to make that happen. So I hope I'm giving you an idea and wrapping this up and putting a bow on it, helping you understand the flux densities that we're working with, of conversions, working with other materials, diatomic gases such as nitrogen, hydrogen. Those are the two basic gases that to build from as far as potential battery sources. And the electron has to be readily available somewhere, and you have to have the resistance to be there. So therefore, automatically within the system, as far as what's running through the series system, if you can envision just a long piece of activated carbon, and as you move through, the resistance gets more and more, the front end gets charged, and we're to tap that for amperage, and we're to tap it for voltage. So it kind of gets interesting that one of my questions in there is, can the same wire be configured to be a bifilar? And the answer is yes, and the hairpin circuit pretty much proves that. It's just where you're tapping into the different potentials on the hairpin circuit. So whether it's straight or whether it's a coil, however it's spinning, it's right there tapping into that unit. So we're going to get this record set up to understanding a little bit more about the dimensions, what we're looking for in the seesaw wave, plasmatic wave that I've been talking about. All this basically came from studying the VTA unit, and just my common understanding of low pressure being the amps and the high pressure being the voltage, and how these work within the systems, but really demonstrating that the heuristics in the metal, which is a memory, we can do the same thing electrically with the electric polarization. So when you're setting this up, you're designing it to actually spin in one direction. And that direction can be either clockwise, counterclockwise. You know, one of the things I love to show is that I'm rotating my arm in a clockwise fashion. Okay, on the screen, it's looking clockwise. Okay, as I'm looking to the back of it, looking down my arm, it's still clockwise. Okay, but when I watch this back, it's going to be actually reverse. Okay, that's always amazed me with this, and getting to people to see that there is a mirrored reflection that's a little bit backwards. So getting people to see the resistance, especially when you're working with a center tap transformer, like I've demonstrated earlier. Let me get my mouse traps off of here. In the system is a conditioned mirrored response, and the electrons, I believe, can be witnessed in this phenomenon and controlled through the mirrored reactance of how that works, either magnetically or through the electric portion. So we're kind of flipping the math around and getting to understand more and more about the electric and radio frequency heating and cooling, as far as making it part of the system that you're actually seeing through the unit itself. In a nutshell, it took me about 23 minutes to start wrapping it up. But what I'm going to do is I'm going to take two mouse traps. I'm going to take them apart, okay, and I'm going to take the hardware off of it. And I cut with a pair of diagonal pliers, you know, just a set of diagonal pliers. I cut these to the width of my mousetrap boards, okay? And so the reason I cut 4 of them right now at this point, and I still have some, I have to find the material, and I'll share that with you. I'm building this on the fly with you. But basically, that's the height of it, and then of course the other board will be on there, and on each side of that's going to be the contact side. Now I am going ahead and using wood in my fabrication, which I know is going to be noisy. I think that actual sound can have an effect on this plasma that I'm talking about, and so more experimentation to be done with that. Honestly, you know, back in the 60s, I used to work with vibrators all the time, and we used them in car radios to produce the 400 volts. And, you know, I've got some somewhere stored in a bucket, the old vibrator tubes. One of the interesting things that was reported by Roy St. Vincent was the winding on the Model T spark coil and on the primary. And I was explaining that to one of my friends the other day, and he said, "Oh, we call that a Z coil." So the Z coil has evidently been around. It's used in amplification for high frequency. And so as we're learning more about the Z coil type configuration, and according to Roy, like he reported, it was wound this way, then straight line back, and then wound the other way, straight line back. I really don't know how many layers. I'm thinking, like I said, whatever your width is and whatever materials that you use, that 9 layers is about all you're ever going to wrap up to with any configuration. And of course, you could use 3, you could use 6 or 9 layers. And then you also have the potentials of making different taps off your design. So when it comes to the sympathetic resonance, which I gave you the building blocks for how to find that sympathetic resonance with common dimensions and how I found those dimensions, just by simply taking your block of wood or whatever, you can build devices to find sympathetic resonance where you can predict where that's primarily going to resonate at. The trick is finding the parametric resonance with all the other chords that are within that by finding the right frequency to make that resonate, and then finding the parametric oscillations within that same coil design. That's where I'm going with this. This is what I'm trying to demonstrate and show you guys. Hope you enjoyed the video. I hope it helps you. Wrapping all this up to making motor designs even better, and whether it's oriental motor controls or permanent magnet motor controls. Like I said, this technology has been around for a long time. It's just understanding and willing to try the various experiments to get away from the same old thing we've always done with commutators and things, and making this motor run purely off of frequency without using the commutator is exactly where I'm going. So plan on replacing this with a slip ring and going for a completely different unit and going with a monopolar magnets in it. So if you hang with me what I'm doing, it looks good on paper, and we're going to find out for sure if it's going to work or not. So please leave your comments. Let me know if I helped you. I'm a great researcher. If you have something that needs to be researched in the field, I probably already researched it one way or another. May have the answer off of memory. But anyway, as you can tell, my phone's ringing and I've got to go. We'll see you guys later. Y'all are having fun. Well, God bless you, because we are.